Okay. In this project, we began by loading the training and the test data, followed by necessary proposals. And the goal of processing is to transform raw data into a format suitable for neural network input. The specific steps include handling missing value by using um, simpler computer to fill missing value, uh, numerical features with the median, and categorical features with the mode, encoding categorical variables using one hot encoder to convert categorical variables into numerical form through one hot encoding. Um, stand, standardizing numerical features by use standard scholar to standardize numerical features, ensuring a mean of 0 and a standard deviation of 1. Feature uh, engineering by creating a new feature such as host listing dynasty and demand score to enhance the model's productive power. And the proposed data is led into training seeds and validation seeds for model training and evaluation. And here, as you can see, our model building, we use Keras sequential API to build a multi-layer MLP, multi-layer perceptor neural network model. And the model architecture is as follows. Input layer is 256 neurons with ReLU effectively input shape matching the number of the features. Dropout layer randomly drop 20% of the neurons to prevent overfitting. Hidden layer 1, it's 128 neurons with ReLU activation. Dropout layer randomly drop 20% of the neurons. Hiding layer 2 is 64 neurons with ReLU activation, and hiding layer 3 is 32 neurons with ReLU activations, and output layer is 1 neuron for regression tests. This multi-layer design aims to capture complex patterns in the data while reducing the risk of overfitting through dropout layers.
So our model was compiled using the ADA optimizer with a learning rate of 0.001. The loss function selected is mean squared error MSE, which penalized the larger errors more heavily. Additionally, mean absolute error, which is MAE, was included as a metric to track prediction accuracies. For our model training part, the model was trained for the maximum of 100 epochs with a batch size of 32, but early stopped training at 24 epochs to prevent overfitting. The validation loss was monitored, and when it did not improve for 10 consecutive epochs, training was halted, restoring the best model weight. So for our graph and the validation loss curve, Here is a graph. The training loss continuously decreased, but the validation loss fluctuated, particularly around the epochs from 20 to 25, where it spiked before the stabilization. This suggests that the model may have started to overfeed to the training data. The final training loss remained lower than the validation loss, further indicating a possible overfitting issue. So finally, about our model evaluation on the validation dataset, the model achieved first root mean squared error, which is RMSE, is 158.23. The mean absolute error is 61. This result indicates that on the average, predictions deviated by the 61 units, and some larger errors contributed to the RMSE value. These metrics suggest that while the model captures the general trends, it may still require further tuning to improve the accuracy.
Here's part 3 is test set predictions. After training the validation, after training and validation the model, we applied it to the test set to generate the predictions. The test set data underwent the same processing steps as the training set to ensure consistent input format. Using the trained model, we predict the test set outcomes and save the results to CSV field with 2 columns, ID and predicted price. By saving the predictions, we can further using this model to using this model performance in real world application, but we still need a lot of things to enhance it. And that is all of our project.